All right, here we go, guys. So I'm going 5-1 slope fields. We're going to go 5-3 separation variables. When I see you guys on Friday, we'll go 5-2. The exponential growth decay in Newton's method, Newton's law of cooling. So our objectives today are recognize and solve differential equations that can be solved by separation of variables. And we're going to use those to model and solve applied problems. There's our academic standard. So we're going to consider a differentiable equation with a function in respect to x and a function in respect to y. So I got an equation with x's and y's, the derivative of y in respect to x. What we need to do, so here's a differential equation with both x and y. What you see happening is we put all the x's on one, so we know how to find the derivative. Come over here now. We're going to put all the y's with the d of y and all the x's with the d of x, and then we're going to take the integral of both sides. Look, what we can do is we can rewrite this and make things happen. It's a pretty straightforward term, and I have a couple of them here. So I have this one. Find the general solution of x squared plus 4 dy dx equals x times y. Okay? So showing how we're going to put everything in differential form, we're going to separate our variables. I'm going to write a couple of these out. But if I go to here, I rewrote it algebraically, and then I take the antiderivative. What's the antiderivative of 1 over y in respect to y? ln y plus c. Now this one you may not recognize. That's an inverse tangent. Excuse me, I would make u x squared plus 4, and we do some manipulation, and we get the plus c. That allows me then to solve for y, and I'm going to do some of these. I'm showing this one first, where we take the e of both sides and we have our new equation. So how about I do some for you together, and we'll go step by step. All right, here we go. Maybe. Get to this problem right. Sorry, guys, I don't have time to go through all that, or I would. Okay, here we go. Let's work this out together. X times y prime minus 3y equals 0. So I want you guys to think about, when you see y prime, we wrote that way many times also. You guys got, let's rewrite that as dy over dx. So let's rewrite this as x times dy over dx minus 3y equals 0. And what we're going to do is we're going to get the x's together with the dx. We're going to get the y's together. So let's go x dy dx equals 3y. So let's multiply both sides. Look up here. Let's multiply both sides by dx. So now it becomes x dy equals 3y dx. You're going, how'd that help me, Mr. Dice? You put the y's with the dx and you put the x with the dy. Well, that's easy. Now that I have a dy and a dx, I can divide both sides by x, and I'm going to get 1 over x dx. And at the same time, I could divide, now I'm just going to divide both sides by what? 3y. So I'm going to get over here on the left 1 over 3y dy. Is everybody comfortable with what we did there? Now, just to make life easier at the end, we want to make y as simple as possible. So I really shouldn't even divide it by 3y. I really should have just divided just by y. Let's take this 3 and put it back over here. So I'm going to erase this, and I'm going to rewrite it as 3 over x. Cool? Now, so here's our rules. We're going to separate, integrate, solve for y. Separate, integrate, solve for y. I've separated. Would you agree? I am now going to integrate. And the antiderivative of 1 over y is the natural log of the absolute value of y equals, and what's the antiderivative of 3 over x? 3 natural log of the absolute value of x, and then we're forgetting something, but I want to talk about it now. Both sides have a plus c. They're two different constants, right? There's a constant over here, there's a constant over here. How about we take the constant over to the left and we subtract it from the constant over here, and I just have one final constant of plus c. Just one constant. Because it's the constant minus the constant, we have a new constant. Whether it's positive or negative, we have it. We good? All right, how do I solve it? So I've separated, I've integrated. How do I solve for y? Take e. Right? So what's the natural log of e? Those go away, and we can drop that absolute value. We can go straight to y equals. Okay, now you got to be careful here. So remember, let's go off to the side here. Let's review algebra. I have e raised to the 3 ln of x. This is equivalent to, isn't it the same thing as e cubed plus e to the, or excuse me, times e, excuse me, that is, what am I doing wrong? That's the same thing as, what's my algebra properties here? I'm messing up. ln of x. Yeah. And, well, no, I'm wrong. When I have a 3 in front of the ln, what can I do? I can put it here, can't I? Don't we have, when we have a something times a log, isn't the same thing as x cubed? So I would think of it this way. I would think of this 3 here. And now these cancel, and I'm left with, and then I want you all to do this. If, to be honest with you, I brought e to the right, I have to bring e to the whole party. So it's really this. So those x cubed cancels, and now look up here, and I'll go through the algebra a little bit more. This plus, these are both e. This is going to be a new constant times k. And I'll go over those properties here in a second. So y equals k x cubed. Come over here. Let's write down a couple algebra rules real quick of log, if you will, a couple of natural log properties. If I have the natural log of a, so these are some properties, plus the natural log of b, how could I rewrite that? ln of ab. Right? So there's one property. If I had the natural log of a minus the natural log of, doggone it, natural log of b, I could rewrite that as the natural log of a over b. And then this is the one I just did. If I have the natural log of a raised to the b, that's equivalent to b natural log of a. It comes from this right here. If I had e raised to the x plus 2, that's equivalent to e to the x times e squared. So look here. E to this is equivalent to e to the c times e to this, and I just made e to the c the new constant k. I'm going to do 2 more examples. I promise after 2 more you'll have it down, okay? So let's go to the next one. So we want to solve dy over dx equals x times 1 plus y. So we need to separate. That's our first step. We're going to separate here. So let's put, can I move this 1 plus y over to here and have 1 over 1 plus y dy, and if I multiply both sides by dx, it becomes equivalent to equals x dx. Everybody comfortable with that? Yes? We have it separated. Separate, integrate. Let's integrate. Okay, now you got to think here a little bit. You got to be savvy. If I made this u 1 plus y, du would be just dy. So it's really the antiderivative of 1 over u, which is the natural log of u. But let's plug back in, what is u? The natural log of 1 plus y. Equals, there's actually a plus c, but we're going to save it. What's the antiderivative of x? 1 half x squared, and then we're going to put in a plus c. Everybody cool with that? Okay, we've separated, we integrated. We're going to solve for y. We're going to do what to both sides? We're going to go e to the. All right? Over here on the left, those cancel, so I'm left with 1 plus y equals, okay, let's see if we can do it again now. So, guys, this is e raised to all this. Can you follow me on that? And going back to that, so it's e to this times e to c, which times e to c we're just going to call a new constant k. So it becomes constant k times e raised to the 1 half x squared. And then what's our last step to solve for y? Subtract 1, y equals the constant k, e to the 1 half x squared minus 1. Now, in the next example, I'm going to give you an example where we can solve for k. We can solve for k. Got it? Here we go. Next example. dy over d of x equals x to the 4th times y minus 2. First step, we need to separate. This should come to us very quickly. We get 1 over y minus 2 d of y equals x to the 4th d of x. Everybody agree with that? You know what? I think I failed to give you the initial condition. Let me give you initial condition. F of 0 equals 0. We have that initial condition as well. That allowed me to find k, okay? That was given. I want everybody clear on here. Look up here. This is also given. This isn't my work. This is given. I just forgot to have it pop up on the PowerPoint. Okay. Separated. Integrated. What's the antiderivative of 1 over y minus 2? Hopefully you got it down now. ln of y minus 2 equals 1/5 x to the 5th plus c. We separated, we integrated, we need to solve for y, bring e into both sides. Now I have y minus 2 equals, let me emphasize it one more time, this is e to all this, so this is this, times e to the c, we're calling e to the c the constant k, e to the 1/5 x to the 5th. We all cool with that? And add 2, y equals the constant, e to the 1/5 x to the 5th plus 2. I tell you initial condition, f of 0 equals 0. So let's plug in and solve for k. So I'm going to plug in 0 for y, 0 for x. Let's see. Let's do some math in our head here. Look up on the screen. Let's see. 0/5 0 times 1/5 0. Hey, what's e to the 0? 1 times k is k plus 2. So what's k, guys? K is negative 2. So we can come in and rewrite the equation y equals negative 2. E to the 1/5 x to the 5th plus 2. I know this was rushed. Here's your assignment from the book. I have a AP question to do together that focuses directly on this. Let's do that. We still have time. Please.